Hello everyone, welcome to our channel Pranav Academy. In the last session, we solved the example 1 and in this session we are going to solve the example 2. Right? So before solving the example 1 and the example 2, you should have to know all the formulas. Right? Yeah, let's start. The question is if angle B and angle Q are acute angles such that sin B is equal to sin Q, then prove that angle B is equal to angle Q. So here they have been given that angle B and angle Q are acute angles, right? And sin B is equal to sin Q, then prove that angle B is equal to angle Q. So let's start. I'm just assuming triangles here. Here there are two triangles, right? Is the first triangle. I don't know the length of the sides. I'm just drawing roughly. Second triangle is big. Okay. Let it be. As you can see here, angle B and angle Q are acute angles. See, this is the acute angle. So I'm just taking as B. As you can see here, it is also an acute angle. Therefore, I am just referring this angle as Q, as the given angle B and angle Q are acute angles. Those who doesn't know what is acute angles are those angles whose value will be always less than 90 degree. So as you can see here, it is not 90 degree, it is lesser than 90 degree. So I can say this angle is an acute angle, right? So it is the angle B, it is the angle Q, right? So I'm just referring it's A, B, C. It will become as P, Q and R. So as we know, they given in the question that sin B is equal to solution. Sin B is equal to sin Q. As sin B is equal to sin Q, what is the formula we can write for the sin B? As you know, we should have to first mark these sides. So it is the 90 degree. The side which is facing the 90 degree is known as hypotenuse. The side which is facing the angle is known as opposite side. The side which is facing the, that is last side, is known as adjacent side. Here, the side which is facing the angle is known as opposite. The side facing the angle 90 degree is known as hypotenuse. And the last side is adjacent. Yeah. So, it is how we should have to mark the sides. Right? You can even refer in my first session of the trigonometry class. I given you the detailed instructions on how we should have to mark. Right. Now, I'm just going to write the sin B is equal to sin Q. So, sin B, I can write the sin B as opposite AC upon hypotenuse, that is BC. AC upon BC, right? Sin B, what is the formula for the sin B? Opposite side upon hypotenuse side. AC upon BC is equal to sin Q for this triangle. Sin Q opposite upon, that is PR upon hypotenuse, that is QR. Right? So AC upon BC is equal to PR upon QR. That means these triangles ratios are same. Opposite upon hypotenuse ratio and this triangle opposite upon hypotenuse ratio is same. I can give the conclusion from this. As you can see here, AC upon BC, that means the ratio of opposite upon hypotenuse is equal to the ratio of opposite upon hypotenuse of the second triangle. Let it be first triangle and let it be second triangle. The first triangle having the acute angle B, the second triangle having the acute angle Q, and in the question they have given that the sin B is equal to sin Q. As they have given in the question sin B is equal to sin Q, I can write AC upon BC is equal to PR upon QR. I can even write this as AC upon PR is equal to BC upon QR. As you can see here, I am just bringing this numerator into left hand side, then it will go to denominator. And that means the left hand side BC is coming to the numerator and the right hand side. So AC upon PR is equal to BC upon QR. So as you can see here, AC upon PR, that means opposite of one triangle upon opposite of another triangle is equal to hypotenuse of one triangle upon hypotenuse of other triangle. Actually, it is the property of similar triangle. It is a similar triangle property we are saying. But before concluding to the similar triangle property, now I'm going to see is that the ratio of adjacent sides of these two triangles is same or not. As you can see here, it is the opposite side ratio of two triangles. It is the hypotenuse side ratio of two triangles. Now I'm just going to see BA upon PQ. BA upon PQ. Right? I'm going to find BA upon PQ. What is the reason to find the BA upon PQ? I'm just finding that the opposite ratios of these two triangles is equal to the hypotenuse side of the ratios of the two triangles. Therefore, I'm just checking out whether if I'm dividing the adjacent side of one triangle upon adjacent side of another triangle, if I'm taking the ratios of these two triangle adjacent side, is it going to be equal to this? Yeah. Let's see. I'm just considering AC upon PR is equal to BC upon QR is equal to, let us assume this is equal to K. Let us assume this is equal to K. Right. K means it is a constant. It might be 1 by 3, 2 by 5, 3 by 5. It might be anything. As it doesn't know the value of these things, I'm just considering as K. Right. Therefore, AC upon PR is equal to K. BC upon QR is equal to K. Right. Now I'm going to find BA and PQ. How to find the BA? As it is the adjacent side. Let's use the Pythagoras theorem here. Right. What's the Pythagoras theorem saying to us? BA is equal to, I'm just trying to solve out here. BA is equal to, instead of writing BA, you use hypotenuse square, that is BC square is equal to BA square plus CA square, that is AB square plus AC square. Right. Therefore, I just want the AB square. Therefore, AB square is equal to, I am just keeping this AB square here itself and moving this AC square to left hand side. As it is going from right hand side to left hand side, it will become, that means there will be a change in the sign. Here it is plus. When it will move to the left hand side, it will become minus. Therefore, BC square minus AC square. AB square is equal to BC square minus AC square. So we found, that means we have to find the BA. How to find the BA? It is AB. Therefore, AB is equal to, when this square comes to the right hand side, it will become as 1 by 2. That is nothing but root. So root of BC square minus AC square. So we found out AB. Right? Like this same, we should also have to find out for PQ. For this triangle, how to find for the PQ? I'm just writing out here. Yeah. So apply the Pythagoras theorem. QR square is equal to, hypotenuse square is equal to sum of the square of the other two sides. That is nothing but PR square plus PQ square. Right? We need PQ square. So I'm keeping here itself. Therefore, PQ square is equal to, it will become as QR square minus PR square. So I got the sides value. Here it is AB is equal to under root over BC square minus AC square upon, I got a PQ value as QR square minus PR square. Right. So how to solve this one? As you can see, this ratio, that is BC by BQ, I'm writing here BC by BQ, BC by not BQ, it's QR is equal to K. As BC by QR is equal to K, I can write the BC as KQR. Like the same, I can even write for this AC upon PR is equal to K. AC upon, yeah, I can write it here. AC upon PR is equal to K. As you can see here, it is AC upon PR is equal to K. Is this visible to you? I don't think so. Yeah. AC upon PR is equal to K. I don't think so it's visible to you. So I'm just rubbing this out. Yeah. Writing from here, that is BC upon QR is equal to K. Therefore, BC is equal to K QR. Like the same for this ratio, AC upon PR is equal to K. Therefore AC is equal to KPR. So instead of writing BC, I can write KQR. Yeah, I'm writing here KQR whole square minus what is this? AC square. AC square in the sense it is KPR whole square upon QR square minus PR square. So I'm just taking out this. It will become as K square QR square, right? It will become as, I'm just writing out here, it will become as K square QR square minus K square PR square upon under root over QR square minus PR square, right? As you can see here, K square is common, so I'm just taking out as common. It will become as K square QR square minus PR square upon under root over, see, as you can see, both are square root, so I can take it as a single root. It will become as single root. Yeah, it's becoming a single root. Yeah, so K square QR square minus PR square upon QR square minus PR square, it will get cancel out each other, right? Under root over K square, so it is K into K, so I can take out 1, so I'm just taking out as K. I'm having 2 times of K. K into K is nothing but K square. If I'm having 2 times anything inside the square root, I can take 1 outside, so I taken out, that is K. So I got BA upon PQ as K. Yeah, even now I can say that AC upon PR is equal to K. Now this ratio BC upon QR is equal to K. Now the adjacent ratio of these two triangles is also equal to K. Therefore I can write this as, I'm just rubbing out these things, right? I think you would have copied. Yeah, so I can say that AC upon PR is equal to BC upon QR is equal to BA upon PQ is equal to K. Therefore, as you can see here, opposite side ratio of these two triangles is equal to hypotenuse side ratio of these two triangles is equal to adjacent side ratio of these two triangles is equal to K. Therefore, each and every side ratio of these two triangles is equal to each other. Therefore, we can say that it is similar triangles. Triangle ABC is similar to triangle PQR. Therefore, I can say the angles will also be equal. Therefore, angle B is equal to angle Q. Hence, it is proved. So, I just shown you how the angle B is equal to angle Q by just proving that the similar triangle property, by showing you the similar triangle property. As you can see here, AC upon PR, opposite side ratio of these two triangles is equal to the hypotenuse side ratio of these two triangles is equal to the adjacent side ratio of these two triangles. It is the property of the similar triangles, right? As it is the similar triangles, my angles are even going to be the same. That's why I wrote here angle B is equal to angle Q, and we proved this.